Hello, I welcome you all. The problem reads a triangular plate made of homogeneous material has a constant thickness that is very small. If it is folded over as shown, determine the location y bar of the plate's center of gravity G. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. We are being asked to determine the location of y bar of the plate's center of gravity G, and the plate is made up of homogeneous material. So when the material is homogeneous, it simply means the material property at every point throughout the whole body of the material is the same. These material properties would include density, elastic Young's modulus, Poisson's ratio, and so on and so forth. And if the material is homogeneous, it simply means the centroid will coincide with the center of gravity, given that the material is within the uniform gravitational field. Alright, so having said that, let's begin solving the problem. So because of these folded plates, this part here, because of this part here, okay, and this part here, the center of gravity will be changed to move towards the y-axis. Without these parts, the center of gravity would remain just within. It wouldn't shift along the y-axis. Okay. So these are the only parts that we are going to consider. So let's name them. To start with, we are going to name this triangle that is made out of two right angles connected back to back, right? You've seen that? Okay, there we go. So that is a right angle there, that is a right angle there, right? You agree? Great. So we'll give it one number, which will just be 1. That is our part number 1. Then the other part that we are going to consider will be these two parts also, these right angled triangles on the sides. We'll give them the same part number. So, and we've been told the thickness for this particular material is going to be neglected. So this is a right angle here, and also this one here is a right angle. These are the same. When you look at this particular material, it is symmetrical about the z-axis. So give this part number 2, and so is this one there. Then finally we have one big part in green. This one in green, we'll give it one part number. Okay. This one in green, it looks to be the largest in terms of area. Great. So this one is going to be part number 3. Great. So we have 3 parts. So what we need to do now is to define its centroid location. This is our 0 point here, this point here. So now let's start with part number 2 and 3, since they are at the very lowest points. Great. So its location, centroid location for a triangle, it will be like so. Let me use, I think, black, something like this, in that direction. I extend it a little bit further. I extend it like so. Okay, let's say I extend it like so, and then let's say it is up to somewhere there like that. Like that. Okay, great. So there we go. So we have this. So this distance here, we'll call it as our y curled 2. We are looking at part number 2. Okay, we are looking for part number 2, curl 2, which is equal to, this is going to be equal to okay, this is y curled 2 is equal to this is going to be equal to 2/3 of the length of this triangle. So 2/3 of, what's the length, is 3. So therefore this gives us a 2 inches. Is that fine? Great. And this apply for part number 2 for both of them. Okay, and then let's define for part 3. We are assuming the thickness is negligible, very small. Part 3, it is going to be, let's imagine it's there like so. It's going to be at the very center. Okay, somewhere there. Does it look like center, this one? Alright, I think this looks like the center. Okay, so there we go. This position here, this is the centroid location for part 3, and is equal to, this is y curl 3 is equal to half of part 3. Part 3 is 3 meters in the y-axis, and half of 3 is 1.5 inches. Is that fine? Great. Then let's go to part number 3. Part number 3, where are we? Okay, I will include also the other part. I think the other part that I left, this centroid location, is just 0. Alright, let me go to part number 3. Part number 3, there we go. Let me get a straight line, something like this, up to there, something like this. Okay, so this one there, this one, this length here, this one here, it is y curled 1 is equal to starting from this point, going towards, starting from 0, going towards the y-axis, is going to be 1/3 of 3, which is equal to just 1. Let me extend this so that I have some space for writing. So y curled 1 is equal to 1/3 of 3, which is equal to 1, just equal to 1 inch. Okay, great. So maybe let me define the last section, because somebody is going to say, why did you leave out that other one? I left it out basically because its centroid location is 0 with respect to the y-axis. But let's include it. So we have this large part, which is centroidal, which is trapezoidal in shape. Okay, let me call it part number 4. And we know that this part number 4 is centroid. The location is just going to be equal to 0. Okay, and that's the reason why okay, but we'll still need this area and so on. All right, so that is trapezoidal, so we need to calculate the area. So let's start calculating the areas. For the first one, let's say area number 1 is going to be equal to, what is area number 1? Area number 1 is half times 2 times 3, which is equal to just 3 inches squared. Area number 2 is equal to, where is area number 2? There are also 2, so we'll say 2 times half times half times 1 times 3, right? So this is also equal to 3 inches squared, right? Yes, it is 3 inches squared. Then area 3 is just going to be equal to 3 times 6, which is just equal to 18 inches squared. Then area number 4 is just going to be equal to, this is a trapezoid, right? So it's a plus b times half times height. So a plus b is a 2 plus, okay, a 2 plus, the bottom is 6 times half times the height which is 6. So this gives us, what does it give us? So it's 2 plus 6 times half times 6. So this gives us a 24 inches squared. Alright, so we have everything. So now let's feed all this information in our table. So we have part, and then we have y cubed, which is in inches. Then we have area, which is in inches squared. Then we have y cubed area, which is just in inches to the power 3. Great, so let's draw the table. We have this like so, like so, like so, like so. Okay, so there we go. How many parts do we have? So we require 4 rows, and then plus for summation. Great. So I think we are good to go. This is good. So let's now fill in this particular table. Alright, so we have part 1, part 2, part 3, part 4, and the summation. So the centroidal position for part 1 we said is 1, positive. For number 2 is, why is number 2? For number 2 we said it is 2. For number 3 we said is 1.5. For number 4 it is 0. Right? And then the area for number 1 it is 3. For number 2 it is also 3. And for number 4, for number 2 it is 3. For number 3 the area is 18. And then for number 4 the area is 24. Great. So let's find the products now. Y by area. 1 by 3 it is 3. 2 by 3 it is 6. 1.5 by 18. What is it? Is it 27? Yes. 27. And 0 by 24 is 0. So let's sum up this. So we have 3 plus 6 plus 27. So this gives us a 36. And then the area we have 3 plus 3 plus 18 plus 24. This gives us a 48. Alright. So now we have y bar is equal to the summation where n is equal to 1 up to 4 of the product of the local centroid by the area divided by the total area. Okay, total area. Okay, and this therefore gives us a 36 divided by 48, which is equal to 36 divided by 48. What do we get? We get a 0.75 inches. Okay, so y bar therefore is equal to 0.75 inches. So let's show this also in our figure where exactly this position is. So this position is here. If I was to show this on this same point there, from there to here, okay, so we are saying this location here, this location there, like so, this location there, this one there is equal to, which is y bar equal to 0.75 inches. So that's where the location for in the y-axis, that is, we are just talking of the y-axis, that's where that's the location for the place center of gravity. Alright, but for this problem to finish, of course, we need also to find the location in the x. Not in the x. In the x it is 0, but in the z. Okay, in the z-axis. In the x-axis is going to be 0, but in the z-axis we will need to have it calculated, but that was not part of the problem. Alright, I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.